Alright, in this video we're going to do the integral formula for the arctangent of x. So it's going to be pretty similar to the arcsine integral that we did in an earlier video. So we're going to use integration by parts here. And again, it's not really obvious that that's what we have to use because integration by parts is typically used for integrating products. This really isn't a product. But again, if you have to integrate something like this, the technique to do it doesn't jump out at you. Just try what you know, try what you think might work. And integration by parts should definitely be one of them. One of the techniques you try. So remember, integration by parts says the integral of u dv equals uv minus the integral of v du. Okay? So even though this isn't a product, we're still going to do integration by parts and we're still going to choose u the same way we always do. So how's that? We use this liate, or whatever it's called, rule. So choose u to be the first thing that appears on this list, the first type of function that appears. Well, we only have this one function here, it's inverse trig. Okay? So we're just going to let u be the only thing we have, basically. So let this guy be u. And then dv, remember, once we choose u, dv is forced to be everything else, including the dx. So u equals arctan of x. dv is everything else, which in this case just means the dx. So if u is arctan of x, then du is 1 over x squared plus 1 dx. Got to have that dx on there because it's du, should be something dx. And then since dv is dx, then integrate to get v, so v is just x. And again, no arbitrary constant on the v in integration by parts. So that was explained in an earlier video. Alright, let's go ahead and continue with this then. So using the integration by parts formula, the integral of u dv equals uv. Okay, so uv, which is in this case arctan of x times x. So arctan of x, so that's uv, minus the integral of v du, so minus x, minus the integral of x times 1 over x squared plus 1 dx. Okay. Okay, so let's go ahead and write this as x arctan of x. And then minus, now what I want to say is x squared plus 1 on the bottom, and then x on top with the dx over here. Okay. Now how do we integrate this? Well, remember when we did the integral of the arcsine of x, if you've seen that video, we had an integral similar to this, and we ended up doing substitution. So that's what we want to do here again, is substitution. So how do we know to do substitution? Well, if it doesn't jump out at you right away, try the techniques you know. Substitution should be one of them. And you know, you can also try integration by parts. I don't think that would work here. It'd be kind of messy anyway. We don't really want to put ourselves through that. So we'll think about, let's try substitution. It's the only other technique we've talked about so far if you've been following along with the videos. Other than the integration formulas, and there aren't really any direct formulas for this. But anyway, when you do substitution, what you're looking for is a function and its derivative, or maybe a constant multiple of its derivative, something like that. So here's a function, x squared plus 1. What's its derivative? 2x. Well, I don't have 2x, but I have x, which is a constant multiple, right? So that's going to work. So now typically we use u for substitutions, but we already used u in integration by parts here, so we don't want to use u again. It's bad form, it's bad practice, it's just bad math etiquette. We want to be mathematically polite. And also it really is technically incorrect, so we don't want to do that. So let's use t. Okay, we already used u and v, so let's just use t. Why not? So t equals x squared plus 1. So dt equals 2x dx. Okay. But again, I don't have 2x dx, I just have x dx. Okay. So let me slap on a 2 in here. Now I have 2x dx, but hey, I just multiplied everything by 2, so that's not okay unless I divide everything by 2 also. Okay? So outside the integral, inside the integral, it's the same thing, it's just a constant multiple. Alright? So now that makes everything okay. And remember, for substitution, there's a couple different ways of thinking about this step. This is one way I like to do because it keeps things kind of simple. So just slap on what I need, and then that means that I just multiplied by a bunch of stuff, so now I have to divide by that same stuff to make it okay. Okay, so I needed a 2, so I slapped on a 2, which means multiplied everything by 2, and then to make that okay, I had to divide everything by 2. Okay? So now let's continue with this. So this equals x arctan x minus 1/2 times the integral of what? Well, remember, this is just t on the bottom, right? That's just t. And then 2x dx, that is dt. Okay, this is dt. So it's minus the integral of dt over t. Okay. And this is really the same thing as saying 1 over t with a dt off to the side, so we can just rewrite that like this. Okay, so you can put the dt on top or put it off to the side like this. It really doesn't matter, but it's maybe more familiar, more common, more custom to write it like this. It doesn't really matter at all. Absolutely no difference. So now this is x arctan x minus 1/2. Now this is natural log of the absolute value of t, so be careful with the absolute values. When you integrate stuff like this, you have natural log of the absolute value, and then plus c. Okay, so now we're not done here. We have to go back to x, right? Because the original problem was in terms of x, okay, arctan of x. So we have to go back to get rid of t. So t is x squared plus 1. So this is x arctan x minus 1/2 times the natural log of x squared plus 1, and then plus c. Okay, now you might be thinking, well, hey, what happened to the absolute values? Well, x squared plus 1, that's always a positive number. Okay, if you take a number and square it, the smallest thing you'll get is 0, right? We're only talking about real numbers here. Okay, so x squared, the smallest thing x squared could be is 0. So if we add 1 to that, the smallest thing this whole thing could be is 1. So no matter what x is, x squared plus 1 is always positive, so we don't need absolute values. Now it's not really wrong to have them, but they're just unnecessary, because x squared plus 1 is already always positive. Okay, so really this is the answer here. So the integral of arctan of x dx equals x arctan x minus 1/2 natural log of x squared plus 1 plus an arbitrary constant. So that's one form of the answer. Now there might be, if you're looking at like a table of integral formulas or something like that, then you might see this in a slightly different form, which is x arctan of x minus natural log of the square root of x squared plus 1 and then plus c. Okay, so where's that coming from? Let's write this here. Okay, so the integral of arctan of x dx could also be given by this, which is exactly the same thing, really. And how is it the same thing? Because remember that rule for logs that says if you have a number times natural log of a thing, or any base log really, that's the same thing as natural log of that thing raised to that number. Okay, so factors on logs can come up as powers inside of the log. So this factor of 1/2 out here can come up as a power. So this would be x squared plus 1 to the 1/2. Okay, so that's the same thing as natural log of x squared plus 1 to the 1/2. And 1/2 means square roots. Okay, the 1/2 power means square root, so it's the same thing as this. Okay, so again, 1/2 natural log of x squared plus 1. That's the same thing as natural log of x squared plus 1 to the 1/2. Okay, it's natural log of that. But 1/2 power means square root, so that's natural log of square root of x squared plus 1. Okay, so that's where that comes from. So you might see it in this form, you might see it in this form, but it really is the same thing. Okay, so anyway, that's the integral formula for the inverse tangent function. So it's x arctan x minus 1/2 natural log of x squared plus 1 plus c, or x arctan x minus natural log of the square root of x squared plus 1 plus c. Oh, and again, also just a quick subtle detail. Technically there's absolute values here, but since x squared plus 1 is positive, if you take a square root with no minus sign in front of it inside of the log, then it's going to be positive anyway, so the absolute values here are also unnecessary, because we're just taking the square root of something positive, taking a positive root of something positive, so it's going to be positive anyway, so no worries there. Okay, so just subtle details there. Anyway, that's it for the integral formula of arctangent of x using integration by parts.